So here we go. So we're gonna keep finding equivalent springs. Now I'm gonna give you a general procedure. Okay, so let's say example. Page 1 today. So we're gonna say determine the equivalent spring K equivalent for the below system at point B. Okay, so let me do the figure. So let's say it's a beam over here, which is going to be hinged. There is a spring here at point A. I'm going to call K sub A. And a spring B over here. K sub B. So it will be point A. This will be point B over here. Length L1 and length L2. So basically, what is it that what you need to do? You need to find what would be the equivalent spring at point B over here. Okay. So let's over here, step 1. Step 1 is going to be to do a fibroid diagram. Okay, so I'm going to put here a note in blue, this one, because it will depend on which textbook or how the problem is set up. But I'm going to put over here, if no force is applied at the location of the equivalent spring, you must add one at that location. So basically, in this case, you see I didn't put one in purpose. So what do we need to do? At which location do we need to find the equivalent spring? At point B. So what do we have to do? So we're going to add one force over here. And B, so let's say we assume that we add a force at point B. Okay, going up. You can do it up or down, it doesn't matter. Okay, so if there's a force going up over here, what's going to happen at point A? You're going to have a force pointing down, no? What should be the value of that force? What is the force of a spring? Kx. So what should be the force of this of the force created here? Will be K sub A, X sub A, no? Does that make sense? Now what should be the value of the force over here? KB XB. Perfect. Okay, so step 2 is going to be to apply Newton's equation, summation of forces equal to 0 and or summation of moments equal to 0 in this case. Okay, so in this case, what type of motion is this really having? Is it translation or rotation? Rotation. So if you look from statics, generally, which of those two equations should define the rotation? The summation of forces or summation of moments? Summation of moments. So in general, we say today, translation is defined by summation of forces, rotation is defined by summation of moments, no? So over here, we can do summation of moments. Something that is very important is that when you take the moments, what do you need to define? About which point you are taking the moment. So about which point are we going to take moments? About point O, no? Okay. Equal to 0. Then something else that is not that important, because if you don't put it, I'm going to assume the default one, which is counterclockwise, will be positive, no? Okay, so I come over here. So if you do this, all right, it would be L1, L2. What should be the equation? What should be the moment created by KAXA? Would that be positive or negative? Okay, so it would be negative KAXA times L1. Then what should be the moment created by the KBX2? KBXB, sorry, no, X2. So it will be negative, but this time what will be the on? L1 plus L2. And then what do we need to add here? The moment created by the force at the point when we need to find the equivalent spring will be equal to what? F equal to L1 plus X2. Okay, so this will be equal to 0. So why do we do all this stuff? So that now we can write down. Okay, if you want, let's do it in 2 steps. F times L1 plus L2 will be equal to KAXA L1 plus KBXB L1 plus L2. So that now we can write F equal to okay. Ka Xa L1 plus Kb Xb X2 plus L1 plus L2 divided by L1 plus L2. So let's call this equation here A. Yeah. So maybe I'm going to do here another figure, okay? A small one just to help you over here. If I apply the force over here, F, now what should we have over here? We should have, what should be the value of the force here? Should be the K equivalent X sub B, no? That we need to find. So basically what we need to do is try to compare this equation to this equation. So what is the problem here is that this needs to be a function of X sub B, no? And this equation here is a function of X sub B and X sub A. Can we find a relation between X sub A and X sub B? Okay, so that's what we do next. So step 3 would be find additional equations or equation from geometry. All right, so let's try to find a relation between X sub A and X sub B. So this is point O, and let's say this is the undeformed. And now do this. Okay, so whatever you want to call this one, similar triangle, or we can do it with a tangent. What can we do over here? For example, you do tangent of theta. Tangent of theta should be equal to what? Could be equal to XA over L1, but it could also be equal to what? All right, XB over L1 plus L2. Okay, so now this is going to give us a relation between X sub A and X sub B, no? Okay, or we can just take over here this equation here, which is going to give X sub A over L1 equal X sub B L1 plus F2. Or this is going to give us what? Remember, we want to rewrite X sub A in function of X sub B, so it will give you X sub A will be equal to L1 divided by L1 plus L2 X sub B. So let's say this is our equation 2. So now, what are we going to do? Now we can just take this equation. We're going to substitute X sub A by this expression and try to see if it will be equivalent to this one, no? Okay? So if you want, step 4 will be to solve. Okay? So in order to solve, what we're going to be doing is substituting equation B into equation A what do we have? So let me just rewrite it. We have F equal to K sub A sub A over L1 plus K sub B A sub B L1 plus F2 divided by L1 plus L2. So let me just rewrite this a little bit differently. So let's say this will be 1 over L1 plus L2 factor of K sub A L sub 1. And what is X sub A? X sub A we know will be equal to L1 over L1 plus L2 X sub B plus KB times L1 plus L2 X sub D. Or we can rewrite this as what? As 1 over L1 plus L2 K sub A L1 square over L1 plus L2 yeah, plus KB L sub 1 plus L sub 2 everything times X sub B. Okay, so now basically what can we say? If we compare this equation to the one of the figure, then what should be the K equivalent? So you want all this term over here should be equal to the K equivalent, no? Does that make sense or no? Okay, so you want to hear comparing above equation to F equal K equivalent X sub B. On the figure, we found that K sub B will be equal to 1 over L1 plus L2 K sub A L1 square over L1 plus L2 plus KB L1 plus L2. Any question? Yes.
That's supposed to be KB or K equivalent.
Oh, K equivalent. That should be K equivalent. Okay, let's do another example, but about something different, and then maybe we can do another one about this one. All right, before the example, let's look at something. So let's do next, we're gonna find the equivalent springs. In series. So this is kind of similar to what you did probably in electrical engineering. So basically, what does it mean that you have two springs in series? Is that you have here a spring K1, a spring K2, okay? That we want to replace by what? By a K equivalent, no? Okay, so as before, if you think about it, we need to apply a force F, and basically here we know that F will be equal to K equivalent. Let me call this one. You will understand why XT for X total, okay? You will understand now. So let's say over here that this spring is going to move a distance X1. And this one can move a distance X2, no? Okay? And this one will move a distance X2. Okay, so if we look at the total spring deformation, the total spring deformation should be equal to what? X total will be equal to what? X1 plus X2. But now, you know that the force by spring is equal to Kx. So the deformation is equal to what? X over X will be equal to what? F over K, no? So what should be here then? The total deformation, X total will be equal to what? Should be equal to F over K equivalent. What should be X1? Yes. Over K1, no? And what should be X2? Plus F over K2. Now what can we do? We can cancel out all the F's. So basically what do we find? We found that 1 over K equivalent equal to 1 over K1 plus 1 over K2. Okay, so this will mean what? That K equivalent should be equal to what? At the inverse of 1 over K1 plus 1 over K2. Yeah? I mean, this is okay. So let's say the above equation can be generalized for n spring in series. So let's say you have here one, two, n. Will give you, oops, the K equivalent. So we can say that the K equivalent will be equal to 1 over K1 plus 1 over K2 plus 1 over K sub n minus 1. Okay. So do you remember you also had, I think with the electrical engineering is not spring, but you have resistors, no? Okay, you kind of do the same. Actually, it's opposite to the resistors because if these were resistors, what would be the equivalent? Would be R1 plus R2, no? But you see the way of defining will be the same thing. So 1, 2, and 3. Okay, so what is the other option? Instead of having the spring in series, we can have them in what? In parallel. So equivalent in parallel. So in this case, let's say we have a spring K1, a spring K2, okay, we want to find what would be the equivalent spring. So in this case, let's see, I did it in blue. So we can have here again X1, X2. But what can you say about this one? Is that if this is moving, X2 needs to be equal to X1, no? Yeah, there's no way that it can move differently, no? You want this to move the same. If you move this bar over here, if you pull this bar over here, this rigid bar over here, the two springs are going to move the same distance, no? Yes? Okay. And this should be here, let's say, got this one X total as before. And we need to put a force like always to make it work out. Okay, so let's see. Let's see, you have a little bit of intuition over here. So in this time, what can you say? The total force F over here should be equal to what? What should be here the force? Here you're gonna have what? A force K1, X1, no? Going in that direction, correct? Yep. And then what are you gonna have over here? A force K2, X2 going in that direction, no? Going in opposite direction. So if you look at it, the force F should be equal to what? K1, X1 plus K2, X2. However, what do we know? You know that X2 is equal to X1. So at the end, what do you have? K1 plus K2 will be equal to X1. And maybe to simplify the notation, maybe instead of here putting X total, let's put 1. X1. That way it will make it easier. Instead of we saying X total will be equal to X1. So now you know that from this side, we should get what? F equal K equivalent X1. So what should be the K equivalent? Okay. Or we can say the above equation can be generalized for and springs in parallel K1, K2, K sub n equal K equivalent. So let's say K equivalent will be equal to K1 plus K2 all the way to Kn, no? Any questions? All right, so let's do something here. Let's do a little exercise. I'm gonna come up with a problem. Okay, I don't have the solution, so you have to do it and I do it as same, or we can do it together. Okay. So 1, 2, 3, 4. Let me put this here. So let's say example. Determine the equivalent spring. Okay, equivalent for the below system before we had point B, let's say point A, okay? I'm gonna make up the problem, so. Okay, so let's say this is our point O. This will be our point A. This will be our point B. But in this case, in order just to make it a bit more difficult, I don't know how bad is going to be the algebra. Let's say this will be K1. This will be K2. And then here, let's say we have K3 and K4. Okay, we know this is L1. We know this is L2. So maybe before solving, what should we do? I mean, this is a problem identical to the one we did before, no? But before solving this problem, what do we need to do? We need to find what would be K sub A and K sub B, no? Okay. So in this case, let's say what would be K sub A. So let's say here at, so let's say black. So at doing blue, maybe at point A. So before we do this, we can say at point A. What do we have? You have K1, K2 in series. What do we want to find? Yeah, but this will be our K equivalent. Let's call it this time K sub A, no? Okay. So by looking at the equation, what should be K sub A? Basically, they are in series. So what do we know? 1 over K sub A should be equal to what? Correct. But let's say 1 over K sub 1 plus 1 over K sub 2, no? Okay. Or we can do over here what? Yeah, K sub A, we can do using the same notation. Will be equal to sum of the inverses. So 1 over K1 plus 1 over K2 inverse. Or it should be what? K1, K2 over. I mean, you can do. I mean, you can do the algebra, no? But I leave it on the general form. Now, do we have at point B? What are we gonna have? K3, K4 should be equivalent here to our KB, I mean, I should have done an up and down. Sorry, you do it up and down if you want, okay? Is the same thing. What should be our K sub B? K3 plus K4, no? Okay, so why do we do all this stuff? So that the above system becomes what? Now we can rewrite, we can redo the figure of this one. But with what this time? This time we can replace this by what? Okay, A. And this should be KB, no? And now basically we can do exactly the same thing that we did on the first one, those four steps. So let's say it would be L1, L2. Okay, so now we go to the four steps. Should be 1, 2, 3, 1, 4, 5. Okay. Okay, so let's go to the first step. What was the first step? All right, so let's do the free body diagram. So what do we need to do? This time we need to find the equivalent at point A. What do we need to add at point A if it's not there? If you look at it, what did I put in blue? What do we need to add at point A? Okay, we need to apply a force. Perfect. So here A, B, we know here this is K sub A, K sub B. We're gonna add a force at point A this time. F L1, L2. What are we trying to find? We're trying to find our equivalent system that will look like. So equivalent system should look like what? Like this, no? So that really over here, what do we have? We have F should be equal to what? I mean, let's do step 2, okay? This is the hard spot, I think. Because once we have the correct figure, now what should be step 2? Apply Newton's equation. Here, just the y should be sufficient, not applied directly. So Newton equation, which one are we going to apply? What type of motion is this behind? Rotation, so that means that we take the moment. We take moments about which point? About point O. We can define counterclockwise. Again, if you write down the moment equation, which are letting me know about which point, is wrong, no? because I could consider it's all A, B, no? So if you don't tell me about which point, I'm not even going to look at what you have on the equation. You need to tell me about which point. Otherwise, it has no meaning, the moment equation. All right? So in this case, what are we going to have? What are we going to have?
What side of the box?
Sorry?
What side of the box?
The left side. And maybe, okay, last time I did it a bit differently, so maybe let's try to do the same thing as last time. Instead of putting the spring, I put the value of the forces. So you want, let's kind of do the same thing. So this will mean what? That over here, you're going to have what? But that will be k sub A, x sub A, no? The value of the force. And this will be, maybe I should put it here, k sub A, x sub A, k sub B, x sub B. The value of the force of the spring. Let me redo the figure. It's correct, but let's just try to do exactly the same thing that we had before. That way will be better, I think. Step one, free body diagram. There's nothing wrong, but I want to be consistent with what we did before, no? So let's see, before we had this figure over here. So we have point O, we're gonna have point A, we're gonna have point B. So before, what do we say? Now, what are we gonna have over here? We're gonna have K sub A, X sub A, no? And here we're gonna have what? K sub B, X sub B. We need to apply a force at point A because that way we're gonna find the equivalent spring. And this should be equivalent to point A, point B. To our force F over here. And then here we'll have our K equivalent X sub A, no? Okay, to follow exactly what we did before. That's basically what I'm copying. Steps 2, apply Newton's equation that we say we're going to apply summation of moments about point O equal to 0. You need to define counterclockwise positive or clockwise, whatever you want, but you need to be consistent. So now this will give you what? Okay, so the amount will be minus KA XA as before L1 minus KB XB L1 plus L2, no? And then what we're gonna have plus F times L1 equal to 0, no? I think it would be better to, okay. So this is for the left-hand side. Let's change it a bit. So this is for the left-hand side. This is the left-hand side. This would be the right-hand side. So now for the right-hand side, what would be the equation? If we do summation of moments about point O equal to 0, what are we gonna have? I mean, we'll have F, correct, you want FL1 minus L1 will be equal to 0. So this is basically will give you the same thing as F equal K equivalent XA, no? But just so that you see. Okay. So over here, what is the point? We need to write down, so if you want, from here, we can find that F L1 is equal to K equivalent XA L1, which is going to give us what we knew, that F equal K equivalent X sub A, okay? This is just to ratify what we knew. So step 3. What should we do? Find additional equation. From geometry. So as before, what's going to be that additional equation? And we did it going up. How did I do it before, going up or down? I think I did it going down, no? But we could do it, let's do the same thing as before. We could do it going up, but it doesn't matter. So this will be point O. So XB, XA, L1, L2. So this time, what are we trying to do? We're trying to rewrite everything in function of X sub A, no? Okay. So if we do as before, what can we do? We can say tangent of theta, or if you want, this is the similar triangles will be equal to what? X sub A over L sub 1, but this should also be equal to X sub B, L1 plus L2. Okay, so as before, if we use this equation, I'm really trying to follow exactly the same structure that we did before. So using X sub A over L sub 1 equal X sub B over L1 plus L2. Now we want to solve for which one? What do we want to do? We want to rewrite what? X sub A in function of X sub B or X sub B in function of X sub A? We need to rewrite everything in function of what? X sub A. So this time we need to rewrite X sub B in function of X sub A, no? We have X sub B will be equal to L1 plus L2 divided by L1 X sub A. So this will say will be equation 2. This will be our equation 1. Two, three, four, five, 6. Okay, so as before, step 4. Well, okay. Step 4 would be solve. So how do we solve? Substituting equation 2 into equation 1. What do we get? Minus k sub a x sub a L1 minus k sub b xb L1 plus L2 plus f L sub 1 equals 0. So we get minus k sub a sub a x1 minus k sub b L1 plus L2 times L1 plus L2 over L1 x sub a plus f L sub 1 equal to 0. So it's going to give us f L sub 1 will be equal to what? Will be equal to k sub a L sub 1 plus k sub b L1 plus L2 over L1 x sub a, or this will give us f will be equal to what? Ka plus kb L1 plus L2 square divided by L1 square. X sub a. And what should be the k equivalent then? This should be the k equivalent, no? So that, what did I put before? So that if you want, you can say comparing to this equation now here, no? The k equivalent is k sub a plus k sub b L1 plus L2 square divided by L1 square. Sorry, yeah. Okay, we still have 30 minutes, so let's do one more thing. Let's do another example. But this time will be a little bit different. I mean, any questions so far? Eighth example. determine the equivalent spring K equivalent for the below system. So this time you have to go back to something we did the other day. Actually, the last thing that we did the other day. So let's see. Let's say we have two continuous beams of different cross section. So let's say this one will have an area A1, length L1, will be done of the material. I mean, let's do same material. We could do different materials, but let's do, let's do, yeah, let's do L2, L2, and let's do different materials. It's fine. So what are we trying to do? We're trying to find what would be the equivalent system, no? Okay, so first thing we're going to do, we're going to replace the top one. So replace the continuous system, which means this one. We can replace it by what? By a K1 and a K2, no? Yeah? So let's say here, where, go look at your notes. What should be K1? On axial deformation. This is basically is moving on the axial deformation. So what should it be? Look back. It's not on the screen. What is it? So will be A1, E1 over L1, and the second one will be L2, E2 over L2. All right? Okay, so then next, what do we do? The equivalent spring of two springs in series is, what should it be then now? So now our K equivalent, what is the one in parallel? We have what?
Series, so now I will pay. How about a web search for it?
Okay. Do we say something else? Okay, so what should be the equation here? We should have, what should be the equation? We have 1 over K equivalent, no? Should be equal to what? 1 over K1 plus 1 over K2. Or we can say that K equivalent will be equal to the inverse of 1 over K1 plus 1 over K2, where, okay, I'll let you do the algebra, where K1 is equal to what? We just said before, A1, E1 over L1, and K2 equal to E2, E2 over L2. Okay, so basically that will be for this chapter. So basically what I was trying to do in this chapter is to transform type of continuous system into discrete system using springs, no? Finding the equivalent spring, okay? So I will probably post an assignment on Thursday about this. Okay, that will be due next week. So next, we're gonna start where you really have difficulties, okay? And I found out last semester is that another title of this class should be structural dynamics. And you had dynamics like about a year and a half ago, some of you know, if not most of you. So basically, last semester I didn't do it, so it did not go too good. So this semester I'm going to do a review of a little bit of dynamics, because the important part or the difficult part in this class is to find the what is called the equation of motions. So this is basically what we're going to be working probably. I think I'm going to spend probably 2 weeks on just learn how to find the equation of motions. Okay, even maybe more, 2 or 3 weeks, okay? So that will be it for the first chapter. And I think today we were able to do the recording, so